Hello everyone. In this video let us understand algorithm of linear searching technique. This is also called sequential searching technique. Before we begin, a small request with you. If you are not yet subscribed to our YouTube channel, please subscribe. Let's get back to the topic. Let us consider array or list of elements. There are 4 elements in this array. Let n equals 4. In this example, the array name is A. As you know, the subscript starts at 0, increments by 1, and ends at n-1. In this example n equals 4, so that ending with the value 3. Let us consider 2 cases. The first is a successful search, and the second is an unsuccessful search. Let's consider 20 as the search value in the first case, and 30 in the second case. At the beginning of both cases, variable found value initialized to 0. 0 means that the element being searched for has not yet been found. The index starts at 0 everywhere. So, let's create another variable I to store and hold the initial value of the index, which is 0. Let's compare the value we need to find with the first element of the array. That is, the positional value of I. Using an if statement.
Key is equal to 20, of I. Where I is equal to 0, that is, of 0 is 25. We are comparing 20 with 25. Is it? Both are equal. No. That is, this is not the element we are looking.
Are there any more elements in the array to compare the element we are looking for? Yes. So, let's continue to next element of the array by incrementing the value of I by 1. And, comparison 20 with 5. But these two are not equal. So, this is not the value we are looking for. So, let's move on to the next item on the array. Now we are comparing the values of 20 and 20. Are both equal? Yes, both are equal. That means we found the value we were looking for. So, stop the search, and exit the looping statement using the break statement. Before exiting the loop statement, we need to change the value of the found variable from 0 to 1. 1 means that the element we were looking for was found. That is, the search was successful. And also collect the location of the searched element. Using the statement, location equals I plus 1. Why I plus 1? Because the actual position of the searched element is 3, but the value of I is 2.
Next, let us move on to second case. Here too, the initial value of the found variable is 0. As mentioned earlier, 0 means that the element being searched for has not yet been found. Next, again the value of the variable I starts from 0. This is because the first element index is 0. And let's start by comparing the value we are looking for with the very first value in the array. That is, the positional value of I using an if statement. Is it both are equal? No.
So, let's continue to next element of the array by incrementing the value of I by 1.
Is it both are equal? No.
Let's continue to next element of the array by incrementing the value of I by 1.
Is it both are equal? No.
So that, let's continue to next element of the array by incrementing the value of I by 1.
Is it both are equal? No. So, we are trying to move to the next element in the array.
But there is no element to compare. We should have stopped the comparison process at the previous step. At that time, the value of I was 3. In general terms, it was n-1. The important thing to note in this case is that the value of the variable found remains 0. That is, search is unsuccessful. Outside the loop. Use an if statement to check whether the variable value of found is 1 or not. If the condition is true, the search is successful. If the condition is false, the search is unsuccessful. That's it. Let's move on and start coding in Python.
First, the value to be searched for must be read into a variable called key, using the input function via the keyboard. Next, observe the picture. In both cases, the initial value of the variable found is 0. So, the variable named found is taken and set to 0. See here, in both cases, the initial value of variable I is 0 and keeps on incrementing by 1. So that for statement is like this. For I in range within parentheses, the first argument value is 0. This value represents the initial value of the index or variable I. And the value of the third argument is 1. This represents the increment value of the index or variable I. Let's determine the end value of the index or variable I, later movement. According to this for statement, the value of I starts at 0 and keeps increasing by 1. For each value of I, we are going to compare the value at position I of an array with the key value using if statement. That is, if key equivalent to of I. If this condition is false, the control automatically moves to the next value of I. If this condition is true, the search is successful. Therefore, the loop should be exited using break statement.
Before exiting the loop, change the value of the variable found from 0 to 1. That is, found equals 1. In addition to this, the location of the searched value should be stored in another variable. That is, location equals I plus 1. If this condition is not met, we will have to continue to the last element of an array. The array contains n elements. So, we need to put n as the second argument in the for loop. After comparing the element to be searched with all the elements in the array, controls automatically exit the loop. The value of the variable found remains unchanged. That is, remains 0. Because we didn't find what we were looking for. Outside the loop, let's check whether the value of the variable found is 1 or not. Using if statement. If yes, then we found the value we were looking for in the value of the variable location. Otherwise, we wouldn't have found the value we were looking for. That's it. This is the end of the linear searching technique. If you like our work, please help us fix the bugs by giving your valuable suggestions and feedback in the comment box. If you are not yet subscribed to our YouTube channel, please subscribe. If possible, like this video and share with your friends and relatives. Any of your reactions and comments will encourage us to create more videos. Thank you one and all.